Hello friends, welcome back to Softwaring channel. In today's video, I will show you how can you get all the reaction forces of statical indeterminate structures by using ANSYS software. So since this is a training tutorial, uh, I am gonna give you all the required parameters used for analysis explicitly. So as you see from the element type, material property, geometrical property, the loading condition, and even the finite element model is given explicitly for you. So as a result, you would like to calculate or you would like to know the reaction force at the supporters. So now I am here to show you how can do this step by step. Keep watching. So once you have understand the problem, what you have to do is just open your ANSYS software. So depending on the version, it will display like this. So in order to such problems, you have to set your preference. That means if you unselect all the disciplines will be display on the main toolbox. So in order to reduce or in order to get all the required things only, just select the select the structural discipline only. So pass by saying okay. So in the preprocessor step, what you have to do, just select your element type. So as you see from the program, the element type is link 180. So I select, so link 180 is select. So just by say close. So you have to do a real constant. So the real constant in this case is an area. So the area must be given here. So our area is 1 inch square. So I just add our area here. What you have to do in this session is just be careful on the unit homogeneity. So now we just select our element type, we add a real constant. So what I have to do is just select the material and interior material property. So in this case, this is structural linear elastic isotropic material. So our modulus of elasticity is 3 times 10 to the power of 7, and the Poisson ratio is not given, so let us take it as 0. Now once we have our material property, what we have to do is just modeling. So in modeling stage, we can create, for example, node in active sense. So we have 4 nodes. So the first one is as the origin, the second is 4 meters from the origin, the third one is 7 inch from the origin, and the fourth and the last one is 10 inch from the origin. So now we have created 4 nodes. So what we have to do, just after creating the node, we have to create an element. So we can create an element by using through nodes. So by selecting the nodes, we can create elements. Once we have created an element, we have to put the boundary condition. So in order to that, we just enter on the load, define load, apply structural. Since the bar is fixed at the 2 ends, we can create, we have to fix on this or this area, so there is no any movement on any direction, so it's fixed. Apply, and at node 4 we will fix. Now after putting the displacement, we have to apply the force. So the force is at node 2. The magnitude is in the y direction. The magnitude is just on the negative y direction, so 500. Apply. Similarly at node 3, 100 in the minus y direction, 1000. So 1000 in the minus y direction, just apply. Now after applying the load, what I have to do is just on the solution stage, we have to solve the current loading step. Wow, good news, the solution is done. So once it says the solution is done, we can extract or we can get the anything we want from this analysis. So in this particular example is we asked to get the reaction force at the support. That means since this is our node 1 and node 2, node 3 and node 4, so what we want from this analysis is just the reaction force at node 1 and the reaction force at node 4 on the respective directions. So in order to get this, we have to get in the general post-processing. From this, we just we want to see on the list form, so you can press on the list results. From this you can, the reaction solution is here. So actually if you want or the reaction force on the y, the x or the z direction, you can select the single one. So as you see from here, the force is applied in the vertical direction. So if you see the reaction force on the y direction is enough, so we select the y direction reaction force only. So by saying okay, we can get the result. So as you see from here, the reaction force at node 1 and node 4 are 6,600 and 900 respectively. So the total values will be 1,500 units were applied on this bar. So the reaction forces at this 2 point or at the 2 fixed end is shown here. So if you want to get other results, you can do by selecting any of the results here. For example, if you want to see the nodal solution, I mean elemental solution, for example, if you want to see the von Mises stress, you can see here. So it will be put on the list form because we get in on the list results. So if you want to plot results, for example, if you want to counter plot, if you want to plot the elemental solution, for example, the von Mises stress, you can see in the plot form. So if you want to animate this problem, you can press the plot control, their animation, deformed shape. So if you want to get all the deformed shape, you can press here. So if you say okay, the structure will deform. So it has very little deformation since it is statically indeterminate. It has very less deformation. So this is all about this particular example. So if you get something from this video, or if you are interested on getting on the coming new updates, please do not forget subscribing the channel. So thanks for watching.